Hey guys, this is Jacob from RoboFlow, here live from Minnesota to give you a video about how to deploy YOLOv5 to a Jetson Xavier NX at 30 FPS. This is really a huge capability to be able to run state-of-the-art object detection at this speed, which is very important for edge AI devices to be able to run in real time, so you can design systems that are making inference very quickly and essentially acting as if they're actually seeing things in front of them in real time at the same frame rate that the human eye can process things in front of it. So now kind of talking a little bit about our setup here, we're going to train a custom YOLOv5S model, and we're going to train that model, and then we're going to take it and we're going to deploy it all the way to a Jetson Xavier NX. So here's a little bit of a picture of the setup here that I have upstairs. You can see here I have my Jetson Xavier NX, and I have a display connected into it. And so this is where we're going to be doing our inference. Now, a quick note on training your custom model. We have a lot of great content at RoboFlow on how to train YOLOv5. I've linked it here in the blog post, and I'll also put a link below in the video. But the first step is to gather your images of what you want your computer to be seeing, and then you're going to load these images into RoboFlow after annotation. So you'll draw bounding boxes around the objects in the images that you want to detect, and then after you've prepared a data set, you can augment it, and then you can send those images through training, and then training will basically give you a model that will do inference afterwards. And you can kind of smooth that all out beforehand. I'm going to kind of run forward with this video assuming that you've already done the training process and you're ready to simply deploy your model to an edge AI device. And so that's kind of where we're starting here. So once you're done with training, you'll have a .pt model. That PT model you're going to take and you want to put it somewhere on the cloud where you can access or on a USB stick. And then once you have it on the USB stick, you'll be able to transfer it onto your Jetson Nano or your Jetson Xavier NX device. So here's a picture of the Jetson NX. So it has various inputs and outputs that you can kind of be sending inputs and outputs through it. So it kind of is the basic setup here for a computer that you would be setting up, but you want to be able to input in your mouse and keyboard. You want to input in your Ethernet for internet connection. And although I don't think you actually need the Ethernet, it can connect to a Wi-Fi automatically. And then also your HDMI display is important so you can visualize things. And then you can also put a webcam port in there if you want to set up the device to be kind of inferencing live. So there's the input ports for your Jetson device. And then the one important thing that you'll need to get it started is a micro SD card. This is what you're going to actually put the image on to be able to boot up, install Ubuntu, and then download the Jetpack 4.4 to actually get started with the underlying software to run your Jetson. So in order to do that, we'll go ahead and go over to the Nvidia Getting Started with the Jetson Xavier NX website, and then once you get over to that website, you can download the Jetpack image, put it on the SD card, and then plug it into the Jetson NX device, and then this will boot up, and you'll be able to log in there, see Ubuntu's there, you'll have your terminal. This is all a very seamless process. Nvidia makes this very easy process for us to get started with. Now, the next thing we're going to use is the Nvidia Jetpack 4.4 PyTorch container. And this is a really important thing to be able to run YOLOv5, because basically we could imagine a world in which we want to run YOLOv5 by building PyTorch from scratch on our Nvidia Nvidia Jetson device. But that's going to be a really big problem, because there's all sorts of different versions of PyTorch, and there's all sorts of other dependencies that you need to be building underneath here that you're going to have just a massive headache going through all these installs. So thankfully, there is the Nvidia Jetpack 4.4 PyTorch container that has already been installed, and this is something that you can download from Nvidia, and you just simply Docker pull this image down. If you're not familiar with Docker, I do recommend learning a little bit about it. You can download this image, then you have the image, and you can kind of start building on top of it. So you can pull the image down and then do some installs on top of it. You can just kind of exec into that image and then start running your training jobs. And so yeah, so that's the PyTorch container. You go ahead and Docker pull that down, and then we'll be building from there. Go ahead and git clone the YOLOv5 repo, and then once you have the YOLOv5 repo, you can install OpenCV and all the other requirements in the repo, and then you can build that repository up, and then once you have that, you're pretty much ready for inference. So now here's a little bit of a peek into running inference on the Nvidia Jetson NX. So once you have all of those environment installs set up, you're going to be able to leverage the detect.py script to get an idea and get a sense that basically you've successfully started running inference on your Jetson NX. So here I have a little bit of code where you're invoking the Python detect.py script, and you're loading in your custom weights in place of the usual YOLOv5s weights. Once you have those custom weights in there, and then they're inferencing on video, images, or webcam, whatever you choose to expose to them. And here I have some printouts of the speed that I'm getting on the Jetson NX with this kind of pristine PyTorch build. And it is roughly 30 FPS. So that's pretty exciting to see. And I would show you a video here, but of a live screen, but unfortunately that's pretty difficult to do on the device. So I just have the printouts here, and you'll have to just take my word for it. And then I have a little bit of some thoughts about making it run even faster. So of course, I'm not going to give away all of the keys to the kingdom here, but I have a few suggestions if you really want to be working to make this run on the edge on the Jetson even faster. So one thought is you can actually shrink the model smaller than YOLOv5s is to even make the model even tinier than it is kind of in its pre-trained setting. The second idea is to use TensorRT. So there's some TensorRT implementations of YOLOv3 and YOLOv4, but these are all things that we can certainly speak about with RoboFlow if you are working to kind of get your devices out there on the edge. You just go ahead and reach out. And so that's all for our video today. Hope you enjoyed. Now you know how to deploy YOLOv5 all the way to an edge device and then run it on a Jetson Xavier NX. This is a very powerful skill to have, especially given how customizable these models are to detect any object in the world. So that's all for today. Thanks so much for watching. Go ahead and feel free to like and subscribe on the bottom. And as always, happy detecting.